Here with me, I have questions from MIT Integration B 2006. We have the integral of square root of x over 1 minus x cubed dx, and integral of x to the 1 over 2 power over 1 plus x to the 1 over 3 power dx. As usual, you want to pause this video and give this a try. Let's get right into it. How do we solve this first one? What if we use trigonometric substitution and say let this x here equal to sine theta. This is going to make this integral look more uglier because we have x to the third power. Adding being we have x to the second power, then trig substitution would have been the best option. What if we express this in terms of another variable such that we have 1 minus the variable squared? Okay, I think that would help. Let's see. So let's say we have u squared equal to x cubed, and let's differentiate this. So if you differentiate u squared, you have 2u du equal to differentiate x cubed, you have 3x squared dx. That means dx is equal to 2u du over 3x squared. Now we want to move this integral which is in terms of x now into another variable u. So we don't need this x squared, so let's express this x squared in terms of u. First, what is x from here? Now x from here is just take the cube root of both sides, so you have x equal to u raised to power 2/3. So x squared, therefore squaring both sides, you have that x squared is equal to u raised to power 4/3. All right, let's now rewrite this integral in terms of u. So we have the integral of now square root. I'm going to split this on this division sign. So we have x. Now what is x? X is actually u to the 2/3 power, square root of that, which is same thing as saying raised to power 1/2, over 1 square root of 1 minus what is x cubed? Of course, that's just u squared. Now what is dx? Dx is actually 2u du over 3x squared. What is x squared? X squared is just u to the 4/3 power. Now we can factor out this 2/3 outside the integration sign. So we now have integral of course this 2 cancel out with this 2, so we just have 2 to the power of 1/3. So we have u to the power of 1/3. So we have u to the power of 1/3 times u. Of course the 2 is outside now, so we have times u. Then of course we can bring this u to the power of 4/3 to the numerator, so we have times u raised to power minus now because we have over, so we have minus 4/3, then du over square root of 1 minus what is still we still have u squared. So let's try to simplify this. Of course, using the index law, we just add the exponent since we have multiplication. So the exponent here is 1/3 plus, of course, the exponent here is 1. and 1 is actually 3 over 3. Then plus minus 4 over 3, it is still minus 4 over 3. So yeah, we just have 1 over 3 plus 3 over 3 is actually 4 over 3. Then minus 4 over 3. This is 0. That means we just have u equal to 0, u raised to the power 0 here. So we can say we write this integral in terms of so of course we have 2 over 3. So we have u raised to the power 0, which is just 1. Then we just have du left. Du 1 over square root of 1 minus u squared. Wow, this is actually nice. Of course, this is actually familiar because if you should differentiate, let's go to the next page. We know that if we should differentiate with respect to u, sine inverse of u, we see that we have 1 over square root of 1 minus u squared. That means if we should integrate square root 1 over square root of 1 minus u squared with respect to u, then we still have sine inverse of u. Now you could put a little bit c there, which is a constant of integration. So let's see. So this integral here, we have that 2 over 3. Then what is the value of this? Of course, just sine inverse of u. So we have sine inverse of u, or arc sine of u, then plus c. Are we done? No, because this is u. Our question was in terms of x. So let's see what u is in terms of x. Of course, using this relationship, that u squared is equal to x cubed. U squared is equal to x cubed. That means u is equal to x raised to the power 3 over 2. So here we have 2 over 3 arc sine u. What is u now? We have x raised to the power 3 over 2 plus c, and this is the solution to this integral. All right, let's jump into the second one. Of course, we can use similar method, but let's see. Now we have 1 over 2 power here and 1 over 3 power here. Of course, this is actually not that good, because what if, since we have plus here, what if we know that if there was x squared here, would have used the trigonometric substitution again, or would have seen that it might be tan inverse of something. We don't know. So let's see if we can actually express this term here, x to the power of 1 over 3, in terms of another variable squared. So let's see. So let's let theta squared equal to x to the power of 1 over 3, such that if we should differentiate this, we have that differentiate to theta over theta raised to power 2. We have 2 theta equal to 1 over 3, then x raised to power. Now that means you have 1 over 3 minus 1. 1 is actually 3 over 3. So we have minus 2 over 3. We have minus 2 over 3. Let's clean this up. and dx. We didn't put the theta there. Alright, so we have 2 theta d theta. Let me rule a line there to differentiate. What is dx from here? Dx is going to be equal to 2 theta d theta over 1 over 3 and x to the power of minus 2 over 3. Let's simplify this. Of course, this is the same thing as saying 2 times 2 times 3, which is just 6. Then we have theta. Of course, x raised to the power of minus 1 over 3. If we bring it up, we just have x raised to the power 2 over 3. 2 over 3 minus 2 over 3. So we have d theta. Alright, is there any way we can how do we... Of course, we want to move this into another variable, theta. So we need to express x to the power of 2 over 3 in terms of theta. Of course, from this relationship, let's see if we can express x to the power of 2 over 3 in terms of theta. So what if we square this? Theta squared, we square it, then x to the power of 1 over 3. If you square this, you have 2 over 3, and that is what we want. So x to the power of 2 over 3 is actually theta raised to power 2, then everything squared. Of course, that's just theta raised to power 4. Theta raised to power 4. So we have 6. We have theta here, then theta raised to power 4 d theta. And okay, all right. Of course, I mean, we have theta raised to power 5 here. Theta raised to power 5. Everything is raised to power 5. Now, how do we express x raised to power 1 over 2 in terms of theta again? Using this relationship, let's bring the relationship down. Theta squared equal to x raised to power 1 over 3. If we should multiply both, if we should raise it to the power of, if we should raise both sides to the power of 3 over 2. Of course, these 3 cancel out with these 3, so we have x raised to power 1 over 2, and that is actually nice. So we have 3 over 2. And this simplifies to theta. 2 times 3 is just 6. 6 over 2, which is just 3, equal to, what is x? Of course, this is just x raised to power 1 over 2, and we are ready to take this integral into the theta world. So we have integral of, what is x raised to power 1 over 2? Of course, that's just theta raised to power 3. Theta raised to power 3 over 1 plus x raised to power 1 over 3. What is x raised to power 1 over 3? X raised to power 1 over 3 is just theta squared. Theta squared. And what is dx? Dx is just 6 theta raised to power 5. 6 theta raised to power 5. Then the theta. Of course, this is just, we can factor out the 6, so we have 6 outside. Then theta raised to power 8. So we have the theta over 1 plus theta squared. Let's see if there's a way we can simplify this. Let's see. Since we have this to be improper, and that means theta raised to power 8. Now the exponent here is greater than the exponent here, so we can use division of polynomials to simplify this. So let's simplify this. So here we have 8 theta raised to power 8, and then theta squared plus 1. So let's divide this by this. So if you divide theta raised to power 8 by theta, so if you divide theta raised to power 8 by theta raised to power 2, you have theta raised to power 6. Multiply theta raised to power 6 by theta raised to power 2 plus 1, you have theta raised to power 8 plus theta raised to power 6. If you minus that, you have theta raised to power 6. Then minus theta raised to power 6 divided by theta raised to power 2 is just minus theta raised to power 4. If you multiply minus theta raised to power 4 by theta raised to power 2 plus 1, you have minus theta raised to power 6 minus theta raised to power 4. And if you should subtract that, you have theta raised to power 4. Theta raised to power 4 divided by theta raised to power 2 is just plus theta raised to power 2. Then theta raised to power 2 multiplied by theta raised to power 2 plus 1, you have theta raised to power 4 plus theta raised to power 2. Then if you should subtract this, you have minus theta raised to power 2. Then minus theta raised to power 2 divided by theta raised to power 2 is just minus 1. Then minus 1 times theta raised to power 2 is just minus theta raised to power 2. Then minus 1 times 1 is just minus 1. So you just have 1 as the remainder. So now we can now write theta raised to power 8 over theta raised to power 2, which is here, as the quotient theta raised to power 6 minus theta raised to power 4 plus theta raised to power 2, then minus 1 plus the remainder all over the divisor. So instead of integrating this, we just integrate this. So let's integrate this. So of course we have 6 times the integral. So let's clear some space. I think this is enough. All right. So 6 the integral of theta raised to power 6 minus theta raised to power 4 plus theta raised to power 2, then minus 1 plus 1 over theta raised to power 2 plus 1, then d theta. All right. If you should integrate theta raised to power 6, you have theta raised to power 7 over 7. So to integrate theta raised to power 4, we have theta raised to power 5 over 5 plus integrate theta raised to power 2, you have theta raised to power 3 over 3, then minus, if you integrate 1, you just have theta, plus, now if you should integrate 1 over theta raised to the power 2 plus 1. Now remember that if you differentiate with respect to theta, the tan inverse of theta, of course you have 1 over theta squared plus 1. So if you should integrate this, then you have tan inverse of theta. So the integral of this is just the tan inverse of theta and plus c. Of course, we are not done because the question was given to us in terms of x. So let's plug back the value of x with respect to theta. So let's use this relationship. So theta squared is equal to x raised to the power 1 over 3. Let me write it here. Theta squared is equal to x raised to the power 1 over 3. So let's see. Now theta, if you should find the square root of both sides, theta will be equal to x raised to the power 1 over 6. So here, so you have 6. Then what is theta now? You have x raised to the power 1 over 6. So if you should plug it in here, there you have x raised to the power 7 over 6, then over 7 minus theta raised to the power 5 now. So you have x raised to the power 1 over 3, then everything raised to the power 5, and further is just 5 over 6, then over 5, plus theta raised to the power 3. Now there will be x raised to the power 3 over 6, which is just 2, then over 3. Then minus theta. What is theta? X raised to the power 1 over 6. Then plus tan inverse of theta, which is x raised to the power 1 over 6. 1 over 6. And we have plus c. So this is the solution to the integral. Never miss a video and subscribe to my YouTube channel, and keep the channel going, and feel free to ask your questions in the comment section below and share your ideas. You could also ask questions, and I make videos on them. Subscribe now, hit that red subscribe button. See you in the next video.